Hi, welcome to the flipped instructional session for Math 08A for Unit 506, Substitution and Elimination Methods. Our objectives for today are to solve systems using substitution, solve systems using elimination, and to identify inconsistent and consistent dependent systems algebraically. So we do have a little bit of vocab here. So let's just I think the best way to get started is just to work in the problems, and then we can kind of come back and talk about these. But a consistent dependent, so this is really just memorization, a system with infinitely many. A inconsistent is one with no solution. So those two are important to just know those two definitions. This is a review of solving. So -6 equals 3 minus 2/5 m plus 1. We always get rid of parentheses, which there are none. Simplify each side, so we can simplify the right. This 3 plus 1 is 4. So now we want to get the like terms together side to side. So we never want to touch anything with the variable till the end. So we minus 4 to both sides. So remember, when we have a fraction, we multiply both sides by its reciprocal. And that gets rid of the fraction. And so this reduces, and we end up with positive 25. So this part was something that you may needed reminding, how to get rid of a fractional coefficient, and we just multiply both sides by its reciprocal. All right, so moving on to the lesson, solve the system of equations by substitution. So we generally use substitution when we already have an equation that has an x equals or a y equals, and we're going to substitute that. So we're going to substitute 2x plus y wherever we see an x in the other equation. And the reason we do this is so we can actually solve this top equation. So we have 3x, so instead of x, we're going to write 2y plus 3 minus 7y equals 10. So before we had an x and a y, and now we just have y's. So when we just have y's, we can solve this. When we had an x and a y, we could not. So we follow our solving. We always get rid of parentheses by distributing. 6y plus 9 minus 7y equals 10. We simplify the sides. 6y and negative 7y is just negative y plus 9 equals 10. So now we subtract 9. So negative y equals 1. So a negative y, we can divide by negative 1 to get rid of that. So y equals negative 1. So that's part of our solution. Remember, the solution should be an ordered pair, x, y. So we have the y. Now that we have the y, we can actually take this, y equals negative 1, and take it back here and substitute that in. So a lot of people get this first part right, but then forget to get this x. So x equals 2 times negative 1 plus 3. X equals negative 2 plus 3, so x equals 1. This is our answer. And we could check this by putting 1, negative 1 into both equations, and they would end up being true. So we could do 3 times 1 minus 7 times negative 1, make sure that equals 10, which that does. And then 1 equals 2 times negative 1 plus 3, check to see if that works, and it does. So our solution, 1, negative 1, is correct. So that's how we use substitution. We substitute one equation in for the other. The second method is called elimination. So what we see here, we don't have an x equals or a y equals, so substitution would be difficult. So the idea is we can add these together or subtract, and we eliminate one of the variables. So this one, we kind of started out tricky. Well, they're all tricky. Okay, so many times we have something like 2x plus 4y equals 8 and negative 2x plus 6y equals 14. So let's just look at this. If we add these together right away, the 2x's cancel. We have 10y equals, let's make that a 12, 20. So y equals 2. And we substitute 2 back into either equation just like before for y. Whoop. So I'd have 2x plus 4y equals 8. So 2x plus 8 equals 8. 2x equals 0, so x equals 0, which is okay. That's still a number. So the solution is 0, 2. So a lot of times we can just straight up add right away, and they eliminate each other. This one, if we added, nothing eliminates. If we subtract, nothing eliminates. So we have to do a pre-step here. So we're going to multiply the top by a number and multiply the bottom by a number so we can get something similar. So what I like to do is I'm just going to multiply the top by 4 and the bottom by negative 6. So I flipped these and I made one negative, so you'll see why. We're going to multiply through by 4 on the top. So 4 times 6x, 24x, 4 times 10y, 40y, 4 times negative 32, mercy. That needs a calculator. 4 times negative 32 is negative 128. We do the bottom. Negative 6 times 4x is negative 24x. See what I did there? They're going to cancel. Negative 6 times 6y is negative 36y, and negative 6 times negative 18 is positive 108. So even though the numbers got big, it'll work out. So now that we have coefficients that'll cancel, we can add these equations together. And when we do that, 24x and minus 24x eliminate. That's why it's called elimination. 40 plus negative 36y is 4y. And negative 128 plus 108 is negative 20. Now we divide both sides by 4, and we get y equals negative 5. So remember, our solution is an ordered pair. So now we take this negative 5 and we can plug it into either equation. 6x plus 10 times negative 5. Make sure you're plugging it in for the right thing. Equals negative 32. 6x minus 50 equals negative 32. We're going to add 50 to both sides now. 6x is equal to 22. I don't like that. Did I do something crazy? Yeah, I didn't add this right, did I? That's 18. Right? I'm freaking myself out. Yep, 18. Divide both sides by 6. X equals 3. So our ordered pair is 3, negative 5. So what this means is if we graph these two equations, they would intersect at 3, negative 5. So that's visually what that means. All right, so this one tells us to solve by substitution. So we talked about before, that means we want to get one of these to say x or equals or y equals. I'm not really worried about using substitution. I would prefer to use elimination when it's set up this way. So I'm going to multiply the top by 3. Let's do negative 3. When I go by negative 3, I get negative 6x plus 3y equals negative 9. And I did that so the x's would cancel out. So I multiplied through by 3 so these coefficients would line up. So when we add these together, negative 6x plus 6x cancels. 3y, negative 3y is canceled. So we're left with a 0. And we get negative 9 and negative 10, which is negative 19. This is false. We ended up with something that's false. This is no solution, which means if we were to graph this, they are parallel lines. So if you get a false statement, that's no solution. This one just says solve. We can use any method we want. It's kind of a cluster. Let me rearrange this. We have 2x plus 3y equals 12. If I move this around, move the 8x, that's positive 8x, positive 12y equals 48. So I'm going to use elimination because I like it better. I'm going to multiply the top by negative 4 because then I'm going to, negative 4 times 2 is negative 8. And I did that, multiply by negative 4 all the way through. And I did that to line up the x's, but what happened? When I add together, I get these cancel, these cancel, these cancel. So I actually get 0 equals 0, which is true. So that is infinitely many solutions. So when I get a true statement, that's infinitely many. And what that means, if we graphed it, would be that these are the exact same line. Be sure to check up your Class Connect schedule for the flipped follow-up and the help lab should you need extra support. Thanks.